Okay, this one's a little bit tougher, this cricket problem. What it simply says here is that the rate of a cricket chirp, in other words, the function, it's a linear function of temperature. In other words, temperature is going to be the dependent. Here's what my work and my scrap work, and I kind of left it up here just to kind of show you. So what they tell me is at 59 degrees Fahrenheit, the crickets are chirping at 76 chirps per minute. If you make it hotter at 65 degrees Fahrenheit, they increase their chirps at 100 per minute. What I did is I started working my way backwards here. And so I started, okay, my last entry here is 100, or pardon me, 65 degrees and 100 chirps, 59 and 76. It looks like I'm decreasing, pardon me, it looks like I'm decreasing by 24. In other words, I'm decreasing by 24 every time. Every time I go down 6. And so that's what I did. I kind of just looked at this trend and first of all said, well, my slope here is going to be decreasing, or pardon me, it's increasing by 4. Because as the temperature gets hotter, okay, really we're going this way, as the temperature gets hotter, I'm increasing by 4 over, or pardon me, 24 over 6, which means I have a positive slope here of 4 because it's 24 over 6, which can just be 4 over 1 or 4. So there's my slope. That's how I'm getting this 4t. In other words, the number of chirps, c, of time is 4 times t, which is this is like your mx, and then I got to find b. And this was tough. This took a lot of work. And so what I did is I kept going backwards and said, okay, minus 24, minus 6, minus 24, minus 6, minus 24, minus 6. When I get to here, the thing is I'm going to start getting into negative temperatures. And so when I look at this one here, what I did is I said to myself, well, let's, just so you know here, if I go down by 1, I should, pardon me, if I go down by, instead of by 24, only 4, that's like 1/6. And so really it's like a 40 here. That's how I found this out. I kind of just guess and check, and you kind of look, and I get this 40. As I keep going here, okay, and this one's a tough one. As I keep going, if you just go from this one, it's minus 24, minus 6, minus 24, minus 6, minus 24, minus 6. And I kept going here until eventually I reached right here. At which stage here, I can't go, you can see that I can't go minus 24, but I can go, because if I go minus 24, I'm going to hit here 0. In other words, I'm going to hit a factor of negative temperature, which is fine, but it's just going to basically give me here, the 0 point here is negative 156. I had to do a little bit of guess and check. This was a tough one, but when I came across here and got this answer, now I have my formula of where this crosses. Now, the negative 156 isn't that relevant because, you know, it says at 90 degrees, well, if I punch in 4 times 90 minus 156, at 90 degrees, these crickets are going to be going crazy at 204 degrees Fahrenheit if they haven't, or pardon me, 204 chirps per minute if they haven't died already because of temperature. So, but they tell me it's linear. How warm is it? And again, I just say set it equal to 120 and I solve this. Calculate the temperature intercept. Well, there's 0 chirps at 40 degrees. That's where I went back to here. Essentially, the negative chirps doesn't make much sense. Really, this is where the chirp, they're probably dead. I said dead bird or dead cricket, I guess. It's not a bird, but probably a dead cricket right here. And so they're just not chirping anymore. And I talk about the slope and what that means. As I keep going, this is what the graph is going to look like. Of course, here's my intercept here. All in this territory right here. It doesn't make any sense. It doesn't make any sense right here. Really, what I want to do is, this is where the problem starts. At 40 degrees, we have 0 chirps, which is just above freezing. So that kind of makes sense. And after that, the crickets start chirping more and more and more. Of course, it doesn't realistically make sense. There's got to be some place up here where it just gets, this is too hot. I don't know where that is, but obviously this can't go linear forever. I mean, eventually you're going to get too hot, and these crickets are going to be dead. The slope just represents the number of chirps per minute with respect to the temperature, and that's kind of what the slope represents here. for this example.